Let's now discuss the key derivation method step in the key agreement procedure. The first thing that needs to happen is the participants need to agree on the particularities of the derivation method. For this example, we're using HKDF using 256 bits using HMAC, and we are going to implement using feedback mode. The parameters that are required for this is first the output from the scheme, then we also need a salt, an initialization vector because feedback mode requires an IV, the label where we can specify what is the purpose of deriving these keys, and then a context, which is an object, complex object, where you can specify some public identifiers for the participants, the public keys, ephemeral and static, and then the nonces if there is any, a protocol or application that is implementing this key agreement, session ID if available, what is the scheme being used, same for the derivation method and the domain parameters. If key confirmation is used, then what is the length of the MAC tag, what is the encoding for these parameters being specified here inside the context, what format is being used, and very important, how the derived keying material is going to be used in terms of what algorithms are going to use that material. The other parameter is the number of bits, 512 for this example. NIST specifies the length in bits. So if we go to the derivation function, remember that before we mentioned that this two-step key derivation procedure consists of two steps, an extraction and an expansion. The extraction is the execution, in this example, of the HMAC algorithm, where the key is the salt and the message is the output of the scheme. This is going to output as a value that then becomes the input for the expansion, where we pass all the other parameters. Then the expansion, one important aspect is the calculation of n, which determines how many iterations we need to perform in order to be able to derive the number of bits that we are being asked. And that is in function of the hash function, because in this case we're using HMAC with SHA-256. So the hash function, which is SHA-256, outputs 32 bytes. If we are requested to generate more than 32 bytes, then that means that we need to have multiple iterations, multiple executions of SHA-256. So n is what determines how many times we need to execute that. This is the iteration. So this is where the keying material is being generated. At the end is the HMAC with where the key is the output of the extraction, and then the message that is being HMAC'd is the previous iteration. That's the first element in the message. For the initial iteration, the value is the IV. So the IV is the first element in the message, then the counter, which is encoded as 4 bytes, then the label, then NIST specifies 1 byte with zeros, and then the context, and finally the length in bits converted into a byte rate, so 4 bytes. And then the HMAC is calculated. So if we execute this, we can see here these are the bytes that are being generated. It's 64 bytes or 512 bits. And for example, the first 32 bytes could be used for encryption, maybe AES. And the subsequent 32 bytes maybe for HMAC, SHA-256, in order to do a digest. that is defined by whoever is doing this key agreement. And that is basically the output of the key agreement procedure. This value, what you see here, is the output of the key agreement procedure.